Hello, my Algebra 1 friends. We are just going to do a quick video on multiplying polynomials. Your learning target for today is I can multiply monomials, and we'll talk about what that means in a second, but monomials by polynomials in one variable. So I'm only going to ask you to tackle ones that just have an x or just have a y. We're not going to deal with multiple variables at the same time. We'll save that for later in the year, okay? So I want to start by reviewing some prior knowledge, which is just distributing, right? So we said the word monomial up here. The prefix mono just means one, right? So that's a polynomial with one term. All right, so in example 1, here we go. We have 4 times the quantity of x plus 3. So I'm going to distribute the 4, so 4 times x. And this 4 out front is one term. So even though it's just a constant, it's still technically a monomial. So multiplying that monomial by the polynomial in parentheses, 4 times x is 4x. And then 4 times 3 is positive 12. So plus sign comes down. And 12. I always want to look and see, can I combine like terms once I do that? In this case, the answer is no, because like terms have to have the same variable raised to the same exponent. All right. So in example 2, now we have 6 times 2x minus 3. So when I think about this here, again, the monomial is 6, so I'm doing 6 times 2x. Remember that your coefficients, the numbers in front of the variable or the constants, those are the only things that are getting multiplied. So 6 times 2x is 6 times 2, so 12. And then the x is going to just be a part of that answer. So we multiply those coefficients. 6 copies of 2x means I have 12 x's altogether, right? Up here in example 1, it was really 4 times 1x. That's why we got 4x. And then I distribute also 6 to the negative 3. 6 times negative 3, I treat this like its own term. So 6 times negative 3 is negative 18. So I will put minus in between as my sign. And 12x minus 18, those are not like terms. So that would be my simplified answer, right? Remember, we're just getting expressions, right? We're not solving, so there should be no equal signs, just combining like terms as much as you can. So now let's look at the difference when I just insert an x into the monomial at the beginning. So now it's 6x times 2x minus 3. This is one piece, one term. So that term is now going to get multiplied by 2x. So just like above, the coefficients get multiplied, 6 times 2. And the variables, we have x times x, right? Well, 6 times 2 is 12, and x times x is technically x to the second power. The exponent tells you how many of that variable is being multiplied together. So the exponent is the number of copies of the variable that are multiplied together. So if you had x cubed, that means you have x times x times x. If you have x to the 5th, that means you have 5 copies of x. Right? So however many x's are multiplied together, that's what the exponent should tell you. So at the beginning, we get 6x times 2x is 12x squared. And then the next piece, we have 6x times negative 3. And just like up above, we get negative 18, and the x is going to hang out on the end, right? These are still not like terms because one has a power of 2 and one doesn't. So that's as far as I can take that. All right. So now let's think about this last one, 6x squared times 2x minus 3. So my monomial is still 6x, but now we have a power of 2, all right? So when I distribute, I'm doing 6x squared times 2x. So it's 6 times 2 and x squared times x, right? I'm just rearranging that a little bit. It's called the commutative property, rearranging, so I can see what should be next to each other. Well, 6 times 2 is 12. And then x squared times x, again, think about how many x's you have total. Well, from x squared, we really have 2 x's. And from x, we just have 1. There's an imaginary exponent of 1 there, even if we don't see it. So x squared times x is x times x times x. So that's really 1, 2, 3 copies of x. So this should be x to the 3rd power. Okay, so 6x squared times 2x is 12x to the 3rd. And then 6x squared times negative 3 is negative 18x to the 2nd. That exponent doesn't change, oops, when we're not multiplying it by another variable, okay? This would be my simplified answer because, again, they don't have the same exponent, so I can't combine them. X cubed and x squared are different things, okay? So to summarize, this is called your power rule. Or sorry, not your power rule, your product rule. What am I thinking? Product of powers. But it's your product rule. It tells us that if we have something like x squared times x, the total exponent is going to be the sum of the exponents that we see all together. So x squared times x, well, that is x to the 2 plus 1, or x to the 3rd power, right? So we add our exponents when multiplying the same variables together. And those variables are often called a base. So x is the base here. You have to have the same base in order for you to be able to add those exponents. So for example, if I had x to the 5th times x to the 4th, altogether I would have x to the 5 plus 4, or x to the 9th, right? X to the 5th is 5 copies of x, and x to the 4th is 4 copies of x. And together we have 1, 2, 3, 4, 5, 6, 7, 8, 9, so x to the 9th. Okay, so rather than having to write this out each time, it's a little cumbersome, we can add these exponents to figure out how many we have. And that's technically what you're doing here, right? We have x to the 2nd, and here there's imaginary x to the 1st, so together that's 3. Here there's 2 imaginary powers of 1, so when you add those up, you get x to the 2nd, okay? So anytime you're multiplying variables, you add your exponents, otherwise the distributing is the same.